Something unusual is unfolding above us tonight, and not in the theatrical, rumor-driven way the internet often imagines. This time, it's real. For the first time in the history of planetary monitoring, an interstellar comet has been brought under a full United Nations planetary defense exercise, an action normally reserved for objects with complicated or uncertain trajectories. Yet officials keep insisting that the comet, designated 3I Atlas, poses no danger at all. The contradiction is what caught people's attention. The moment the exercise began, the global astronomy community noticed an abrupt shift. Observations scheduled months in advance were suddenly redirected, deep sky surveys paused their routines, and telescopes across every continent, along with instruments orbiting Earth and Mars, were assigned to an intensive 2-month campaign. Scientists publicly maintained this was simply a well-timed drill. But the scale of activity said something different. Amateur astronomers comparing notes saw a timeline that didn't align with NASA's calm public briefings. If 3I Atlas were behaving like a typical interstellar object, why would coordination servers, emergency scheduling channels, and shared data relays, normally activated only for unpredictable bodies, burst to life? Then came the images. One after another, from Spain, Thailand, Norway, Virginia, and dozens of backyards, the data showed the same thing. 3I Atlas wasn't acting like a natural wanderer from deep space should. The Spanish long exposure frame revealed a coma so stable it bordered on geometric perfection. Even with star streaks smearing across the sky, the core of the comet remained circular and crisp, as if something inside were holding its shape with uncanny precision. Chaotic sublimation doesn't make perfect circles. Thailand's data added fuel to the mystery. Despite poor transparency and heavy clouds, the core looked nearly identical to the Spanish image. After enhancement, the inner glow formed a rain, an actual rain, surrounded by layers of evenly spaced halos. Comets don't produce concentric shells like that unless their jets are astonishingly stable. Norway's contribution arrived hours later, and this one triggered the most debate. With only modest exposure time, the tail appeared sharply defined, and along its outer edge, a faint curl spiraled outward. Not the random sway of dust, but a structured twist, almost as if the outflow were rotating in a controlled manner. Natural rotation alone can't produce a tail so neatly organized. Around the world, amateurs noticed the same emerging thread. The core remained perfectly circular, the halo expanded more rapidly than models predicted, and the tail seemed to be tracing a consistent rotational pattern. Every independent observation pointed to a stable center driving a symmetrical set of emissions. Something about the comet was enforcing order rather than chaos. The Virginia Wide Field shot deepened the puzzle further. It captured an extended tail stretching far beyond previous detections, thin, coherent, sharply defined even where the detector sensitivity dropped. Real comets shed dust unevenly, causing their tails to blur or fade. This one acted like a finely drawn line. By then, whispers had reached professional circles. A few astronomers admitted, quietly, never on record, that 3I Atlas wasn't following the rules. Interstellar comets, especially, are supposed to be unpredictable. They're loaded with volatile ices and tend to tumble erratically. But this object's jets held their direction day after day, resisting the normal torsion that should have twisted them. Infrared measurements added another layer of anomaly. The comet's coma contained an unusually high concentration of CO2 relative to water and carbon monoxide, suggesting an extremely cold formation environment or a chemical fingerprint unlike anything previously catalogued. Even that didn't fully explain why the jets maintained such consistent angles. At the same time, amateurs began reporting slight, rapid brightness pulses, tiny spikes that briefly intensified the halo before fading. These pulses didn't appear in the smoothed official light curves, but when independent observers compared notes, a pattern surfaced. a short brightening, an expanding outer shell, and then a sharpening of the tail, all while the core remained unchanged. It was as if a stable engine sat at the center, wrapped in shifting vapor. By this point, a simple fact had become impossible to ignore. 3I Atlas wasn't dangerous, but it was different enough to warrant sustained, coordinated monitoring. And that was precisely when the UN activated its exercise. Inside observatories, the shift was immediate. Schedules rewritten. Calibration routines change. Instruments pointed toward a single visitor crossing our sky. Teams accustomed to leisurely comet monitoring switched into high-cadence tracking, attempting to pierce the blinding coma and determine the nucleus's exact position. This is notoriously difficult even with well-behaved comets. With this one, it bordered on guesswork. The jets that should have rotated or flickered stayed locked in place. Their stability complicated every attempt to measure the nucleus hiding beneath. Some theorized that the comet might be rotating far more slowly than expected. Others argued for vents so firmly embedded in the structure that they remained fixed regardless of spin. But several researchers acknowledged, again, privately, that neither explanation fully accounted for what they were seeing. The comet wasn't just stable, it was consistently stable, almost mechanically so. Then there were the accelerations. Tiny, persistent deviations in the comet's predicted path began showing up in the astrometric data. These weren't the erratic nudges caused by uneven outgassing. They were soft, steady, directional. The kind of non-gravitational push that hinted at something continuous rather than chaotic. This type of behavior is exactly what a planetary defense exercise is designed to test, tracking an object whose motions don't match normal expectations. Official agencies said everything was routine. NASA denied any cause for concern, ESA echoed the sentiment, and the International Asteroid Warning Network insisted the exercise was merely a scheduled practice. Yet behind the scenes, more assets joined the watch. Mars orbital telescopes were folded into the network. High-performance processing nodes, usually shared among multiple programs, were suddenly dedicated to Atlas-related computations. The observation density tripled. Private observatories received discreet notices asking them to prioritize the comet. Maybe it truly is just a rare opportunity, an exotic object passing through our system, offering a chance to sharpen the world's defensive and observational capabilities. Maybe the UN saw an ideal moment to practice coordination on something strange but harmless. But another possibility lingered in the minds of those watching closely. Perhaps officials wanted more data before making definitive statements. Perhaps they were waiting to understand the symmetry of the core, the stability of the jets, the chemical quirks, and the persistent micro-accelerations before ruling out more unusual explanations. The comet's behavior wasn't threatening. It was puzzling. And puzzles in planetary space tend to attract caution. As the observation campaign intensifies through the coming weeks, the mystery will either dissolve into clear physics or deepen into something we've never documented before. The world isn't watching because of danger. It's watching because 3I Atlas is rewriting what we thought interstellar comets could be. Visitors like this don't come often, and when they do, they reshape our understanding of the space between the stars.